Alright, so in this next set of videos, what we're going to take a look at is going to be a couple of different topics. So we're going to be going through, essentially we can break down into two major concepts, which are going to be dealing with exceptions through this first half, and then we're going to look at advanced I/O in the second half. So going through the first half, this will include things like understanding what exactly exceptions are. So every time that we've seen these errors in our programs that throw these exceptions, what are those? How do we maybe come up with a more elegant way to catch those exceptions so that our program doesn't just stop just because of perhaps just a minor error, and also how we might be able to create our own custom exceptions that we can use for more specific or more customized descriptions whenever an error occurs. And then in the second half for the advanced I/O, we're going to be looking at things like random access files, binary files, and object serialization. So for this first video, we're going to go through a quick introduction to exceptions. So I'll show you just a very small amount of code related to this, and then also talk conceptually about exceptions. So to start off with, we're going to go ahead and create a new program. So we're going to call this our exception demo. And right here, what we're going to go ahead and do is just create our class header and body. Have our main method. So our public static void main, and our string array of arguments. And right here, what I want to go ahead and do as a simple example of this, I want to create a program where we just ask the user to input a number, and then we're just going to print that number back out to the console. So to do this, we're going to grab the scanner class. So we'll include our import from java.util.scanner. We'll come over here, and we'll go ahead and create an object of the scanner class. So we'll make a keyboard object, and we'll be reading from our standard input. So we'll do system.in for our new scanner object that we create right here. The other variable I'll go ahead and include is going to be our integer, so that we can get a number from the user. We'll hold that in a variable and then print that out just a little bit later in the code. So we'll say int, we'll say input number, and we can go ahead and initialize this to 0. We'll then go ahead and create our print statement to request that input from the user. So we'll say system.out.print, please enter a number. And then just underneath this, we'll go ahead and take our input number, and we will assign to that the next integer that they give us. So we're going to use our keyboard, and we'll use the next int method from the scanner object that we created. And then finally, at the end of this, we'll just go ahead and print this out to the console. So we'll have an additional print statement, and we'll say the number you entered was plus our input number. Okay, so once you've got all that, we'll go ahead and compile this and run it, and we'll test it out with a couple of different inputs. So we'll come over here, and we'll compile our exception demo. And then go ahead and run this. Alright, so we've got our little request right here. Say please enter a number. Let's just give it a simple request, or a simple input. Let's do the number 10. So push enter, and we'll see the number you entered was 10. But let's say we take a slightly different approach with this. So the expectation here is that we're going to give it a number like 10. The way that we know that we're expecting that is because the method that we specified here was nextInt. So the thing that we need to give it is something that matches up with what nextInt is looking for, which is an integer value. That is to say, like a whole number, including any negatives or 0. So if we put something that is not a whole number, say like maybe we just type out the word 10 and we push enter, well, now we get into a bit of an issue where we get this exception right here. So there's a sort of an error or a mistake somewhere in the program. And if we go through this, we'll see exception in thread main, and then it's going to say java.util.input mismatch exception. So in addition to mentioning that we have this exception right here, we can also see right here at the very end of this first line, it's going to tell us precisely the type of exception that we got. And when I say type of exception, I mean that as in like a data type or like a class type. So as you can see right here, we're following that same casing that we've seen for all of our custom classes, say like this exception demo that I created. And the reason that you're seeing that is because of the fact that when we deal with either just a general exception or any of these specific types of exceptions, these are all different classes that exist in the Java API. And you can actually see right here if you look at the entire thing that we're looking at right here, we've got java.util.inputMismatchException, meaning that this is actually a class that came from the util package, just like our scanner. In addition to that, we've got some additional information that's provided here. I'll come back a little bit later on to talk more about these error messages to elaborate a bit more on this additional information that we're getting. So for now, we'll focus primarily on this, and we'll focus on these different types of exceptions that we get. So to elaborate a little bit more on this, I want to go ahead and provide a quick breakdown. So we're going to consider that hierarchy of classes that I showed before. So at the very top of this hierarchy, we know that we have our object class. And then just underneath that, we're going to have another class that we refer to as throwable. So this is part of where that terminology comes from. So whenever we deal with an exception that occurs somewhere in our program, we would say that we are throwing an exception, and that's based on the fact that we're using this throwable class. And as we'll see in a moment, whenever we want to try to handle that exception, the way that we describe that process is catching it. So it's a combination of throwing exceptions and then catching exceptions. So throwable will inherit from object, just like everything else. For this particular case, I'll simplify our arrow notation, show that point up to here. From here, we then have two branches that we're going to deal with. So on the one side over here, we can talk about, the error class, and then over on the other side is where we're going to have our exception class. So the majority of the things that are going to be included in this exception class are what we're going to be dealing with when it comes to trying to catch or handle them. When it comes to error, this in combination with one other subclass of exception. In a moment, I'll explain briefly that these are going to be two things that we cannot deal with, and I'll also explain why. But for now, we'll go ahead and complete the rest of this hierarchy. So we've got these two right here, both inheriting from throwable. From here, we will then go ahead and break up our exception. Essentially, we're going to have two types. So the two types of exceptions we're going to have, we will include one right here, which is going to be for our runtime exceptions. I'll place it underneath it, just kind of right there. And then the other one is going to be essentially any other kind of exception. So to give you an example of this, let's say we use another type of exception that we're pretty familiar with at this point when dealing with files, which is the IO exception. And then, of course, from there, we can also talk about individual or more specific subclasses of IO exception. Say maybe things like the file not found exception. We'll use that as one example that we could find underneath it. Even that wasn't long enough. Let's see. I'll just place it about right there. Okay. So we've got this whole hierarchy, and the two main things that I want to talk about briefly are the error and the runtime exception. And the main reason that I want to address both of those right now is because of the fact that these are going to be unique from any of the other kinds of exceptions or things that come from the throwable class, in the fact that these are going to be two things that we cannot try to catch or handle. The reason for that, when we talk about runtime exceptions, the reason that you would get a runtime exception is because of some kind of syntactical or programming error. So this is going to be because of a mistake that you made somewhere in the code that causes this runtime exception. So rather than trying to catch or handle it, the correct way to address a runtime exception is to review the code that you wrote and just correct any mistakes that you might have made. In the case of error, this is going to be very distinct from many of our exceptions in that the error class is meant to address very critical errors. A good example of this would be like running out of memory in your program. So if you run out of memory, generally the best way to approach that is from a hardware standpoint. You just have to get more memory. So there's not really programming way to address that kind of issue. So when we deal with error and runtime exception, these are going to be what are known as our unchecked exceptions. So we'll just place that right there, and we'll place it right here. So those are going to be our two types of unchecked exceptions, meaning that these are going to be things that we never try to check for. And then everything else is going to fall into the other category, which is checked exceptions. Okay, so everything that we have over here, these are going to be our checked exceptions. And these are going to be things that, as the name would imply, we are going to check for. And in order to check for these types of exceptions, there are two things we can do. So the first is something that you're already pretty familiar with, which is just including a throws clause in your method header. So for example, whenever you're dealing with, say, file I/O, trying to deal with either writing to or reading from a file, you typically saw some kind of additional portion that you would include with your method header where you'd say throws I/O exception. And that way then you could go ahead and include various classes from your I/O package that deal with input and output to files. The other way that we could try to address this, say we don't want to try to use this throws clause, we could instead use what are known as try and catch blocks. So the way that this is going to work is I want to, whenever I specify this or make this call to next int, saying that I want to go ahead and capture the next integer that the user inputs, and I want to assign that to input number, I'm going to go ahead and put that into a try block. So we're going to include the word try right there. Then go ahead and move these over. And I'm going to go ahead and put both of these lines into here. And then underneath this, I'm going to include a catch block to go with it. So we're going to do a catch. And the thing that I want to try to catch right here is going to be this particular exception that we saw here. So I'm going to specify, when I put catch in these parentheses, the type of exception that I'm trying to catch. So I'll say input mismatch exception. And this is actually going to be sort of like a parameter, say like this parameter that we use for our method. So in addition to specifying the data type, I also need to give it a variable name. And a pretty standard variable name when we deal with exceptions like this is to just use the letter E. And then right here, what I can go ahead and do is essentially treat this almost like a, sort of like a method all its own. And we can just include some code right here. So just go ahead and do a simple print statement, and we'll just say system.out.println, and we'll say you did not enter a number. Go ahead and save that. And now what's going to happen is whenever we encounter the code inside of this try block, basically what we're going to do is, as this would suggest, we're going to try to execute this code, and if we happen to encounter an exception somewhere along the way, we're going to stop trying to execute the code inside of this try block at that line and immediately go to the catch block. From there, we're going to essentially be applying the type of exception, this specific kind of exception that we caught. We're going to be using this variable name within the scope of it. In this particular case, I will be excluding that for now. I'll address this in a little bit more detail going into the next video. For now, we just want to see a very simple print statement to see what's going on here. So we'll go ahead and try this out. We will compile this. And since I've also included this, which comes from the util package, I'll need to make sure that I import that as well. So since we've actually introduced the input mismatch exception, this also comes from the util package. So to use this in my code, I've got to import that too. So we'll go ahead and import that. We'll go ahead and try this once more. So we'll compile that. And then we will run it. And now what we're going to go ahead and do right here. So first we'll go ahead and test it with valid input. So just do the number 10 again. We do that. And we see in this case, because we didn't have an exception at this line, we just executed all of the code inside of this try block. So we also went ahead and ran this print statement. And we printed out the number you entered was 10. But the one thing we didn't execute was whatever was in the catch block, because we didn't catch that exception inside of this. So alternatively, if we run this again and we put something that will cause an exception, we push enter, now what's going to happen is we're going to stop execution inside of this try block at this line right here. So we never get to this print statement inside of it. and instead we come over to the catch block. We're going to set up our input mismatch exception that we just caught. It's going to be given this variable name of E, and then we're going to execute the code inside of the catch block, which is going to be this print statement, which we see right here. You did not enter a number. Okay. So this is just a general idea about exceptions. So as we can see right here, we have these different kinds of error messages that we can provide. And one of the other things that I want to go ahead and clarify now, for the sake of security, I want to briefly address the idea of how we can go about specifying a particular type of exception, or essentially specifying to the user what the exception was without necessarily providing so much information that that maybe another person other than the intended user could use that information in order to fix the error in a sort of malicious way. And a good example of what I'm talking about deals with a login screen. So I want to very quickly introduce this concept. So we're going to say something like username right here, and maybe a password right here. And the usual expectation is that you're going to put in a username and a password, and what would typically happen is you would type these two things in, you'd push your little button to try to log in. So you'd have a login button right here at the bottom. And whenever you push this button, if either one of these two things does not match, you would likely expect a warning message to come back from that telling you that some part of these login credentials was incorrect. And so what you want to be careful about is making sure that whenever you specify that there's something wrong with your login credentials, that you don't accidentally say so much about what's wrong with it that some unintended user could inevitably break into somebody's account and then start accessing all of their information without them knowing. So the general idea here is that whenever you provide one of these error messages like this, and you're also doing something like, say, trying to catch the type of error, you generally want to try to make sure that these two things are as general as possible, while still at least being able to provide enough information for the user to understand that there is a problem. So to give you an example of this, we'll go ahead and remove this import statement, and we'll remove this input mismatch. So it instead is just doing an exception so that it's a bit more general in that sense. And then also right here, rather than just saying you did not enter a number, we might say something a little bit more general like say just invalid input. So something even more generic than what we had originally. So if we come back over here, we'll go ahead and recompile this and run it again. And so now what we'll go ahead and do is anytime any kind of exception is thrown, we'll just go ahead and catch it. Doesn't necessarily matter if it's an input mismatch, just anything in general will cause it to enter this catch block. And then the message that the user is going to see doesn't necessarily give away too much information about what the user's input was or what was wrong with their input. So now if we put something like, say, the word 10, we'll just see invalid input here. Okay. And so that's half of what we want to cover. The other half of what I want to address is going to be something that deals with slightly more complex exceptions or errors that we could run into. We'll see a little bit more of this when I get into the next video and I start to address not just dealing with the scanner class, but also taking a look at try and catch blocks using reading and writing to a file, so dealing with file I/O. And in addition to being able to provide these error messages to let the user know that something went wrong, if possible, we also want to look for ways in which we can possibly correct the issue, or at least give them an opportunity to try again. So what we could do is maybe right here, in addition to doing all of this, we could also maybe include some kind of loop that we go through. So we could say something like while their input is not yet valid, so maybe we'll do a boolean. We'll say is valid, say this is initially false. We can then go ahead and include as long as it is not valid. We want to go ahead and input it right here, and once they've gone ahead and given us a number that works, just before we do that print statement, we can go ahead and change is valid to be equal to true, and then we'll have all this code inside of this while loop. And so now the way this is going to work, we've got our Boolean is valid. We're going to be checking for as long as it's not valid, meaning as long as this stays false. We're going to keep going through this code. And what's going to happen is whenever the user provides an exception right here, then we can go ahead and go into the catch block, and we don't move into this line right here. So we're never going to change is valid to being true. And then one other thing I want to go ahead and include, since I already know about this rather bizarre issue that I would like to avoid, I'm just going to go ahead and include another next line right here. There's a bit of an issue that we could potentially run into that I want to try to avoid, which is that this message right here might hit this, and it will end up just repeating the process of asking the user to input something. Okay, so we'll just go ahead and run this much right now, and we'll see how that looks. So compile this, run it, say please enter a number. So if we do something wrong, say like 10, say invalid input, and then we'll go ahead and enter right here, waiting for a number. So we'll do 10, and then we can just say the number you entered was 10. Okay. Okay, so at this point, this is going to wrap up just about everything. I think one additional thing I want to include, one additional thing I'd like to also go ahead and include is just another repeat of this statement, just to make sure that we've got that as well. So we've got this right here, and then just underneath that, we can include one additional print statement to repeat the statement. Okay, I think that would be a bit more thorough. So if we do this, say invalid input, and then ask them to repeat the process, please enter a number. So now if we put in 10, now we can get it. Okay. All right, so this will cover everything. So at this point now, we'll wrap up on this introduction to exceptions. Going into the next video, I want to elaborate a bit more on this try-catch mechanism. We'll also introduce another block that comes with it, which is going to be the finally block, and we'll also explore another more complex set of exceptions other than just dealing with the scanner class by also taking a look at file IO.